morning students. Myself Dr. Bharti Patil, working as an assistant professor physics in Maharaja Jivajirao Shinde College, Srikonda, Ahmednagar. We have started our syllabus related to solid state physics, related to TYBSc class, and we have started our chapter number 2, that is X-ray diffraction and other characterization techniques. In today's lecture, we are going to solve few of the examples based on this chapter. Let's read first example. The example is calculate the distance between two lattice planes which give first order diffraction at an angle of 26.42 degree with molybdenum X-rays of wavelength 0.75 angstrom. So our example based on to calculate distance between two lattice planes. It means that there is one plane and another plane and you have to find out this distance. As we know that the distance between two planes is called as interplanar distance and it is denoted with letter D. So we have to find out what is the value of D, that is interplanar distance. Then what are the given things? So given things are, what is given? First order diffraction. First order diffraction means what? We know that in case of Bragg's law, we have seen Bragg's law. Bragg's law. What is Bragg's law? Bragg's law is nothing but 2d sine theta is equal to n lambda. Reflected X-ray will be in phase if path difference between them is integral multiple of lambda. So 2d sine theta is equal to n lambda, where d is interplanar distance, theta is the angle of diffraction, n is the order and lambda is the wavelength of X-ray used. So we have to find out the value of d, and in given the first order, that is n value is given. N is equal to first. First order means 1 at an angle of 26.42 degree. That is theta is given. Theta is equal to 26.42 degree. And one more thing is given, that is wavelength of molybdenum source is given, and it is, that is lambda is given as 0.75 angstrom. And what we have to find out? We have to find out the distance, that is D, interplanar distance. As we know that the wavelength is also a distance and interplanar distance is a distance. So if you want, then convert it into either centimeter or in meter, or there is no need to convert this for this example, because this is also going to have the same unit as angstrom. So let's try to find value of D by using Bragg's law. Here 2d sine theta is equal to n lambda. Hence D value becomes n lambda upon 2 sine theta. Now substitute value of n. Value of n is given as first order, first, into value of lambda. Lambda is given as 0.75 angstrom divided by 2 into sine of 26.42. If we substitute all these values, then value of D come out as 0.843 angstrom. So what is the value of D? Value of D is 0.4843 angstrom. So by using Bragg's law, that is 2d sine theta is equal to n lambda, we have found out the interplanar distance, that is distance between two parallel planes, and it come out as 0.843 angstrom. Let's try to solve second example. Second example is, for a certain BCC crystal, the 110 planes have separation of 1.181 angstrom. These 110 planes are irradiated with X-rays of wavelength 1.54 angstrom. How many orders of Bragg's reflections can be observed? This is the example. So in this BCC crystal is given and 110 plane is given. Plane given, so given plane given, that is plane we are mentioning with HKL values, and it is given as 110. Have separations of 1.181 angstrom. Separations of means what? Interplanar distance D. So D is given as 1.181 angstrom. Then next, these planes are irradiated with X-rays of wavelength. Wavelength of X-ray is given and we are denoted it with lambda. Lambda is equal to 1.54 angstrom. Then, how many orders of Bragg's reflections can be observed? How many? How many? Means we have to find out the maximum order possible by using this information. Maximum order possible, that is n value is equal to how much? Or max. And max is equal to how much? So we know that we can use Bragg's law to solve this example. What is Bragg's law? Bragg's law is given as, we will try to solve it here. By using Bragg's law, that is 2d sine theta is equal to n lambda, we have to find out the value of n. So n is equal to 2d sine theta upon lambda. But here we have to find out the maximum orders possible. When we have to find out the maximum orders possible, that is for n max theta value, we have to take it as 90 degree. When we take theta value as 90 degree, sine theta, that is sine 90, becomes 1. Sine 90 becomes 1. So this formula for n max gets simplified as 2d upon lambda. 2d upon lambda. Now substitute the values of d and lambda. Here theta is not directly given, but as we have to calculate the maximum order possible, when we have to calculate maximum wavelength possible, then we have to substitute theta value as 90 in the crystallography. So sin 90 becomes 1 and n max becomes 2d upon lambda. Let's substitute the value of d. D is given as 1.181 upon lambda is given as 1.54. When we substitute the value of d and lambda, this value comes out as 1.53. But we know that as the n max is a number, so fractions are meaningless. So maximum order possible, maximum or the maximum orders possible is 1. So in this example, we have again used Bragg's law, and in previous example we have calculated the value of d. Here we have calculated the value of maximum order possible. Let's try to solve one more example. Example is given as a BCC crystal is used to measure the wavelength of some X-rays. The Bragg angle for its first order reflection from 110 planes is 20.2 degree. What is the wavelength? The lattice parameter of the crystal is 3.15 angstrom. So BCC crystal is given, then a wavelength of X-ray that we have to determine. What we have to find? We have to find what is the wavelength of X-ray. Then what is the information provided? Given is that the Bragg's angle for first order reflection. We know that first order reflection means n is equal to 1, and Bragg's angle is given. Bragg's angle is given as, means angle of diffraction theta is equal to 20.2 degree. Then next, reflection from 1 planes means HKL plane is also given. HKL plane is given as 110. When plane is given as 110, it means that H value is equal to 1, K value is equal to 1, and L value is equal to 0. This is also indirectly given. Then we have to calculate the wavelength of X-ray source, and one more thing is given, and it is lattice parameter. Lattice parameter is nothing but the cube edge or the edge. So A is given as 3.15 angstrom. Then by using this information, you have to find out the value of lambda. As we know that in Bragg's law, there is, in this chapter we have seen two formulae. First one is D is equal to A upon square root of h square plus k square plus l square. That is relation between interplanar distance and the edge. So this formula we have seen in chapter number 1, and there is one more example or formula, that is Bragg's law. 2d sine theta is equal to n lambda. So in this formula there is no any lambda. In this formula there is lambda. It means that we have to use this formula. But if we use this information and try to find out lambda, then we will see that n is given as 1, means n is available. Then theta is also given, but we have to find out lambda, and d is not given. So in order to calculate d, we should use this formula first, find out the value of d, and substitute this value of d in this formula and find the final value of lambda. So we will start our example with this formula, that is the relation between interplanar distance and the edge. So we will first substitute these values and find the value of d. So value of d, that is interplanar distance, is equal to value of a. A is given as 3.15 divided by square root of h square. H square means 1 square plus k square. It is also 1 square plus L square means 0 square. So this value comes out as 3.15 divided by square root of 1 plus 1, 2, and this value d is come out as 2.227 angstrom. This value we have obtained as 2.227 angstrom. Now we have to find out the value of wavelength. So let's use Bragg's law. By using Bragg's law, 2d sine theta is equal to n lambda. Find out the value of lambda. So lambda is equal to 2d sine theta divided by n. But as the reflection is having first order, so lambda will have its value as 2d sine theta. So 2 into value of D. Just now we have calculated value of D as 227 angstrom into sin theta. Sin of theta is given as 20. Sin of theta, that is 20.2 degree. By substituting these values, one can find out the value of lambda, and this lambda value come out as 1.54 angstrom. So by using these two formulae, we have calculated the value of lambda, that is the value of wavelength of the X-ray source which is used to diffract this crystal. Thank you.